Welcome back. Today we will discuss an epichemistry question. The link to this question is given in the description of the video. The question is, a new compound is synthesized and found to be a monoprotic acid with a molar mass of 248 grams per mole. When 0.0050 mole of this acid is dissolved in 0.500 liter of water, the pH is measured as 3.89. What is the pKa of this acid? I will suggest you to pause the video here and try to solve this problem by yourself. Hope by now you have already solved this problem and chose the right answer. Now let us solve it together. So, a monoprotic acid is usually written as this, Ha. When dissolved in water, it dissociates to a proton and its conjugate base. So, monoprotic. Mono means single, so it gives rise to a single, and protic in terms of protons, so it gives rise to a single proton. So, from the question, it says 0.0050 mole of this acid is dissolved in 0.500 liter of water. So, here we can find the concentration of this monoprotic acid in terms of molarity. So, we know that molarity is number of moles of solutes dissolved in 1 liter of water. So in this case it will be 0.0050 divided by 0.500. Let us just find out how much is that. So it is 0.0050 divided by 0.500. So it is 0.01. So 0.01. This can also be written as 10 to the power minus 2. So this is what? This is the concentration of the monoprotic acid. Now second, they say that the pH is measured as 3.89. We know pH determines whether a solution is acidic or basic. The neutral pH is 7. So anything below that is an acid, anything above 7 is a base. Since it is an acid, so it's below 7 or 3.89. Now pH can be written as log to the base 10 concentration of proton in terms of molarity, and that has been given as equal to 3.89. So from here we can write that the concentration of proton equals 10 to the power minus 3.89. And from the dissociation we can see that it gives rise to the same number of moles of proton and the conjugate base. So it is as well the concentration of the conjugate base. So the concentration of the proton and the conjugate base, they both are 10 to the power minus 3.89, and the concentration of this monoprotic acid is 10 to the power minus 2. Now the question is, what is the pKa of this acid? pKa. So the pKa is actually negative log to the base 10 Ka. So what is Ka? Ka is the dissociation constant for acid. The A stands for acid. Now how we write the dissociation constant for this monoprotic acid? We can write it as Ka equals concentration of the proton times the concentration of its conjugate base divided by the concentration of the undissociated monoprotic acid. That's how the dissociation constant of an acid is written. Now this Ka actually quantifies the strength of the acid. More is the value of Ka, means more is this concentration of the proton and the conjugate base. That means the acid is dissociated more, so it is more strong. So in order to find the value of pKa, we will have to find the value of Ka, and to find out the value of Ka, we need to find out the value of the concentration of proton, the conjugate base, and the monoprotic acid. and actually we have all these values ready. So let us just substitute it. So I have found out that the concentration of hydrogen ion and the conjugate base both are 10 to the power minus 3.89. So it will be times 10 to the power minus 3.89 divided by what is the concentration of the monoprotic acid is 10 to the power minus 2. So from the rules of exponent multiplication and division, we can write this 10 to the power minus 3.89. We are adding these values, minus 3.89, and for division we subtract, so minus 2 will be a plus 2. Now let us just find out what is the value of this. So we have minus 3.89 minus 3.89 plus 2, which is minus 5.78. So let us just write it is 10 to the power minus 5.78. So all we need to do is we need to substitute this value of K here. So minus log to the base 10 to the power minus 5.78, which is basically this, the both are negative, so it becomes positive 5.78. So we have determined the value of pK for this particular monoprotic acid. Now let us see the answer choices here. Okay, so we can see that C is the right answer, which gives 5.78. Thank you all for watching my video. Please like my video and subscribe to my YouTube channel Circle Research and Education. Here I post videos on test prep questions that includes epichemistry question, epibiology question, and math question from ACT, SAT, PSAT, and STAR test preps. In the description of the video, I have put a link to this Khan Academy article which talks about the weak acid-base equilibria. This can be useful for further references. Dziękuję. See you in the next video then. Happy learning.